Our next slide is providing some rules with respect to the order in which we specify initializer list elements. So the general rule is that the first element on the constructor initializer list should be corresponding to the first data member in order of the class layout, and then the next element is the next data member on this list. So it's very simple because remember we want to maintain the order in which everything is constructed, and then also expect that we have a predictable order of destruction. So this is just an important rule. Some compilers actually will not enforce it, but still I think that this is in terms of the style and clarity of what is happening during object constructor, I think this order should be followed. So here in the example of class point, we would like to be able to use the order of the data members of this class, and that should be the order in which we specified the list of our elements on the constructor initializer list right here. And see, this is an example of a warning here. So just remember that this order should correspond to this order. I also find it very, very important that when I add something new, a new data member to the list of variables here, member variables of my class, it's much easier for me to locate all of my constructors and be able to uniformly make modifications to their initializer lists. And therefore, you know, you're just doing something. You just doing yourself a favor by following this order. So I suggest that you always remember about the simple idea of initializer list order on constructor initializer list. There could be some little things happening here and there with the initializer lists. For instance, consider this constructor of class point, which is declared right at the top. So we have the constructor that takes three parameters. And what we do here is that we say, okay, so we'll initialize this first. This is a reference to another class, right? So there's something, so we provide a reference to this class. And then we take this reference and populate it with whatever reference were provided. So far, so good. Then we take the next data member. So we follow the constructor initializer list order. Everything is good. We initialize it like this. And then expecting that this has been already initialized, thinking that this is all ready to go, we use it here to initialize the next data member. I would say that MX at this stage could still be garbage. It depends on your debug and release build and compiler from compiler. So I would just at all costs I would want to avoid this type of coding. Basically, don't use those as parameters to populate other data members of your class. So basically, the idea is that you can use the same variable right here, variable x, and not the member, which could still be garbage. And by the way, nice example possibly of Geiger principle, which is garbage in, garbage out. So the idea behind garbage in and garbage out, of course, is that if you accepted some kind of garbage, expect that this garbage will persist, and whenever there is time to start using this variable, it still be a garbage because it was not correctly initialized in this case. Just something to avoid. Simple. Again, this is a simple rule, but do not expect this to be perfect in terms of, despite the fact that we're discussing the order of member initialization, still, you know, you should not be casually doing something like this. And at all, I would I would avoid doing this. Another keyword which is very important is const. So const is a way to tell our compiler that something is read-only. So const is a way of us programmers saying read-only, immutable, constant. By the way, in Java, the keyword that Java is using is final. In C++ and in C, it's const. So some things shouldn't change. So just like in our world, if you take the length of the circumference of the circle and divide it by the diameter, it's one of those fundamental constants of our universe. And so, it would be probably, incorrect from every perspective not to use constant to qualify this variable as constant, right? So whenever we deal with true constants like pi example right here, we should be using a const qualifier. What it simply means is that this variable becomes immutable, becomes once initialized remains constant. And when this expression itself is a constant expression, in the latest C++ standard, we also recommend to, and again, this is just a place for me to type something, I'm not going to retain this. A better choice is to use constant expression keyword compared to just const, because whenever, if you observe that this expression is fully known at compile time, there is no doubt about this value at compile time, we should say const expression instead of just const, which provides even stronger definition of the constant. It truly becomes a compile time only object. And therefore, at runtime, we may not even need to waste any memory storing it in computer memory. If this was using some sort of function call, so that we don't know what this function returns back, then we would use const. Okay, but in general, just remember that there's other version of const expression. So const makes everything better. Compiler can optimize the code. Some silly bugs could be eliminated simply because things are constant and they're not supposed to change, and they don't change. You can use precompiler defines, but const is always preferred because const does not remove the type of the variable. So when you do your computations and use this variable somewhere in your formulas, compiler will be able to recognize the data type very well. And if you use define instead, compiler is confused and is not as good as understanding what kind of data type you may be using in different contexts. Const is a type modifier. Okay, so it becomes, so double becomes constant double. In other words, this double pi becomes read-only double pi. So that's the idea about the type modifier. And all const variables must be initialized. So you cannot just leave it like this without initializer. You have to provide something to initialize this variable. So I'm going to remove this code from my file because I've used it only as a placeholder for this demonstration.